Hello everyone, this is Shirish Kulkarni, student at NJIT Cybersecurity Masters Program. Today, this is a small demonstration that I'll be showing of how a distributed system can integrate and work together as a solution within a AWS cloud environment. So this is part of the one of those project assignments given by Professor Mr. Christian Burcha at the NJIT. So the problem statement is we'll be given two EC2 instances, EC2A and EC2B. Both will be Linux instances, and they work in parallel. So the objective is to run two Java programs on each of these instances. The first instance is supposed to read 10 images from an S3 bucket and perform object detection of the object detection and in the images. So when a car is detected using recognition as a AWS service with a certain percentage of confidence, the index of that image is basically needs to be stored in an SQS queue, which is again another AWS service. Now the second instance B running an EC2 instance and the second EC2 instance, it basically reads these indices of images from the SQS, and as soon as these indices become available, it starts performing the next level of image recognition through the same recognition service to find out if those images contain any text. So this is in short the problem statement. And so what I'll be doing here is I'll be demonstrating both of these applications running on EC2 instances, EC2A and EC2B. So and I'll be running the first part of the program on EC2A, where it will basically um, uh, analyze the images in the S3 bucket, those 10 images in the S3 bucket, and push the indices of the file names into the SQS queue. And later, the EC2 instance, the Java application in the EC2 instance B is going to uh, go and poll these image indices, which are file names, and then perform the further image processing for text recognition in the same images. Ultimately, once this is done, so at the after all the images are processed, there is the output.txt file which needs to get populated with the results that the second stage of the image detection has after this second stage of image detection has happened. That is after identifying the text in each of those images. So here, let me first start the first part of the application. Right now, I am in the, as you can see, this is EC2 instance A, and this program assumes that we have set up the credentials and the EC2 and the AWS service credentials as a prerequisite. So let me first uh, just try to run the application. So this is basically a Maven based execution. So we'll see a pom.xml file here, and we'll have a Java execution through Maven. We'll see EC2. I'll be running the EC2A application here, and before that, I would like to show you before I run this application, I would like to show you the the SQS queues in the AWS console. You can see there are these two queues are basically are of our interest: SQS FIFO dot FIFO and SQS FIFO B dot FIFO. So FIFO SQS FIFO dot FIFO is right now containing around 80 messages. So let me first try to purge that queue and make it like a clean instance. So here we go. We have purged the queues, and now we should see zero images or zero messages in it. Okay. Now let me go back to EC1 instance and run the first Java program. So now the expectation out of after running this Java program would be to see the queues getting populated in the SQS with the list of file names which are chosen by the recognition AWS service, which contain the um, car object in those images. So let me run this program now. While waiting for the application to get executed. I hope there should not be any errors. Yeah, there you see the images are getting recognized and they are getting the indices of the file names are getting pushed to a queue. Now let's go back to the queues and see, look at the messages here. Let me refresh this. So you should see messages coming up in this particular queue. Let me refresh it and you see there are 8 messages there. So these are required messages that the file names that get pushed to this queue. Parallelly, you can also see this queue getting populated. So we'll come back to this queue later. Okay, let me go back to EC1 instance. You can see um, these are the file names of the images that contain the car as an image embedded within them. All right, so the part one execution has successfully been done. Now let's go to part two, which is EC2 instance B. So here, as you can see, I'll be running the instance to EC2. Right now, I'm in EC2 instance B, as you can see the highlighted text here, and I'll be running the second part of the program, which is EC2B dot the Java file, or the Java executable. So now this program basically goes and starts polling um, the uh, the SQS queue and then starts detecting the text inside those images. So as you can see, it has started fetching 3.jpg because 3, as you can see here, 3.jpg is the first file in the SQS queue to be processed. So once the image processing is done for 3.jpg, as you can see, these are the words that it could identify, or the characters or text it can identify in this jpg file 3.jpg. Now once this is done, it moves to the next file 6.jpg to analyze it. There it takes around close to a few seconds, around 20 seconds to process those images. There is a bit of delay that has been given here for practical purposes for avoiding any race conditions. So image 6 is done. It's looking for image 5.jpg. Now, based on the output that we see here, it looks like the image 6.jpg does not contain any of those text. There's no text associated, I mean, that the service was able to identify for image 6.jpg. Now let's quickly verify these. So 6.jpg, right? I have a copy of those images that I have kept. So let me show you. So this is the 6.jpg as you can see here. So you don't, as you know, it is identified accurately. There is no text here associated, seen here for this particular image. Similarly for image 5.jpg, you don't see any images, any text in that image. So let me see with 5. As you can see, this is another 5.jpg. This has no text within it, so it's not recording it. Now let's look at 1.jpg if it is having these text embedded within it. Let's go to 1.jpg. So as you can see, this is, let me expand it so you can see this as a text BR8167, and this is some text here, and it is identified with 1.jpg. You can see BR8167. This is one of the text, and the confidence level you can see is more than 80% around. It's very sure that this text is BR8167. Now it further proceeds to image 2.jpg, where it doesn't again find any text. and then it has further processed the 4.jpg, which contains this text. Let's check if this really has any text or not. So there you go. Yeah, you see here YH19OTZ. So 4.jpg YH19OTZ. This is the text that, and the confidence level is 99%. So this is how it is able to record this. Now, wherever you see the confidence level for the text being more than 80%, all these entries will be basically recorded inside the output.txt file that will be seeing once the processing is done. So now this is the now let's see, this is currently the program is processing 7.jpg, which is I believe the last in the SQS queue. And let's quickly check. Now that you can see this program is still running, and let's go and quickly check the um, mm, let's quickly check if what's the content in output.txt file. So let me go to EC2 instance B. I think I came instances, and EC2 instance B is this one. Let me connect to it. This is another session that I'm starting with EC2 instance B to check the content of the output.txt file. So this is EC2B instance, and we will be now checking the EC2 user. You see here output.txt. Now let me see what is written. So as you can see here, all the details of that, whatever text was identified for each image, file name 4.jpg, text is OTZ, and type whatever was like identified, which was more than 80% on the confidence level. So as you can clearly see, these values are getting recorded, whatever has been observed. So images 3, 1, 4, and 7, they contain text which has more than 80% of confidence level as per the image recognition algorithm running on the AWS Rekognition platform. Okay, so now this is one test. Now they can see these are only single entries of the files that you see. Like you have three, all the text associated with three here, and then file 1.jpg, all the text associated with the 1.jpg, and then 7. Right now, the one of the important functionality that I would like to show about this is now the SQS inherently doesn't have a trigger mechanism or a push mechanism. So our program running on EC2B is continuously in a polling mode. So as soon as I start, injecting some more images here, you know, uh, EC2 instance on B should automatically start processing without any manual intervention. So let's wait and see. If it starts taking up 3.jpg again. See, as you can see, it has started processing 3.jpg again, and the moment it one queue puts the value, the moment value gets inside a queue, this automatically starts processing. So this is one way of we can say, a kind of having a push, a trigger mechanism. Rather, it's not technically a trigger, but this is kind of a workaround to go around, go for or have the trigger mechanism similar to what trigger mechanism can feel like. So and this keeps on happening. It takes up processes all the images that get into the queue. So if you look at the queue structure or the queues here, you can see this number should get double now. Let me, yeah, see 8, it was, now it is 16, and then there are other messages that are getting processed in the queue FIFO-B, which basically this queue is a queue which is used by the service running on EC2 instance B. Now, to part of the design, this first queue is basically used for controlling the back pressure. So any of the back pressure or the piling up of messages is handled by this queue. Now this queue will always remain in a very light mode. The moment it processes all the information, it basically deletes them and keeps itself very light in terms of processing. So as you can see, this number gets reduced as and when it starts, processing all the queues and all the entries in it. So ultimately, you should see this queue getting to a state where it has zero messages available and zero in flight. Yes, there is. You can see from 3 to went to 2, and then it should now happen slowly. It should move to the next message, and then this should ultimately become 0. So, so in short, all the back pressure of the messages in the queue will be handled by the first FIFO queue, and the actual processing will be handled by uh, of the images will be handled by the queue number B. You see, and ultimately we should be able to see zero messages in this queue. This is a bit slow. Probably if we are using lab instances, otherwise it's pretty fast in the usual production environments. So as you can see here, the number of messages in the queue B has completely been is been 0, as it indicates that all the messages in it are been consumed. And let's go back to check the content of the file here on the EC2 instance. I believe it is somewhere here. Yes. No, this is EC. Oh, here it is. Now we should see this file getting appended with the latest results. You can see now. So you'll see another set of these are this is the first set of images that are getting the text identification has happened, and this is the second set where we send the images for in the next second batch of processing. So this can uh, as many as you want, you can just keep pushing to it, and the service is capable, or the rather the Java program is capable of handling as many batches as much as possible, supported by the platform. So in case if you have any questions, do let me know, please. This is a short demo that I wanted to um, show um, to my friends and my colleagues. So if you have any questions, please do get back to me. Thank you. Bye bye.